Hello everyone, welcome to Nrcm. This is Shravani and I am going to explain operating system of Unit 4 and the topics are swapping and memory partitioning techniques. Next, moving on to the slide. So first here we will be discussing about the swapping. So what is swapping? Swapping is a memory management technique and it is used to temporarily remove the inactive programs from the main memory of the computer system. So any process must be in the memory for its execution, that we all know that, but it can be swapped temporarily out of memory to a backing store and then again brought back into the memory to complete its execution. Swapping is done so that other processes get memory for their execution. Due to the swapping technique, performance usually gets affected, but it also helps in running multiple and big processes in the parallel. So the swapping process is also known as a technique for memory compaction. So basically low priority processes may be swapped out so that the process with the higher priority may be loaded and executed. On the other hand, like the procedure by which any process gets removed from the hard disk and placed in the main memory or RAM, commonly it is known as a swapping, as shown in the diagram. So here I wanted to draw and show, like see, this is the main memory and consider this is the backing store, or you can consider it as the secondary memory. So in the main memory, so whenever the program is executed, or in general, so if you write the program, so once you will run the program, okay, once you run the program, then what happens? So the process or the program, so process, or you can call it as a program, the program will be stored into the main memory for execution, because as main memory is very crucial, so here space is very important in the main memory. Okay, so the program will be stored in this main memory, and that process, that is called as swapping. Swapping is, it is ready for execution. So after running or after executing the program, so then what happens? So then after completion of the execution, once after getting the final output, so when we close the program, then the program will be again swapped out to the backing store, or you can call it as a secondary memory. So this is called as swap in and swap out. So sometimes what happens, there might be priorities, like suppose consider this is the process P1, or okay, as shown in the diagram. So consider this is the P2. So P2 is, so consider this P2 is it is stored from the secondary memory to the main memory. So now P2 is executing the program. Okay, so P2 is executing the program. Then what happens? So suddenly, it is executing the program. So suddenly what happens? The other process, which is called as like P3. So P3 arrives. Okay, there is one more process which is present in the secondary memory. So that is called as P3. So now what happens? P3 arrives into the main memory. Okay, it arrives into the memory. Then this P2 will be swapped out. So here this P2 will be swapped out and the execution of P3 will be done. P3 will be done. Once the P3 completes its execution and it swaps out, then again process P2 will resume its execution. So this is generally called as swapping. Okay, there are some advantages, or or we can say like benefits. Here the swapping technique, what it will mainly help the CPU to manage multiple processes within a single main memory. Yeah, with the single main memory, like multiple processes can be swapped in, swapped out based on the process. So it will be, so here CPU will not be idle. Okay, here CPU will not be idle. And next, this technique helps to create and use virtual memory also. So that will be the advantage of swapping. Next moving to the memory partitioning techniques. Like memory partitioning techniques are like, there are two ways of partitioning of the main memory. The main memory can be partitioned into two ways. So first is like single partition, and second is like multiple partition. So this single partition allocation, here what happens, the main memory is divided into two parts. In this single partition also, main memory is divided into two parts, and operating system resides usually in the lower memory, Okay, and user processes that held in higher memory, and relocation registers used to protect the user process from each other. I hope you understood. I'm repeating again. So your operating system, so in a single partition, what happens? So the memory will be divided into two, and here what happens? Like operating system will be memory stored in the low memory. And coming to the user processes which are held in the higher memory, and relocation registers are used to protect the user processes from each other. Okay. Next is here, and base register will be there. In this base register contains the value of smallest physical address. Okay, base register contains the like within the limit which is the smallest physical address that will be storing it, and limit register contains the range of logical address, and here each logical address must be less than the limit register. And as we discussed this point we have discussed previously. And here memory manager, it maps the logical address dynamically. And coming to the single partition, it cannot support for multi-programming. We can prefer multiple partition allocation for if you want to use a multi-programming. So like multiple partition is used for multi-programming. Okay, and multiple partition also, it is further divided into like several ways as shown in the PPT, as shown in the slide. So first it is contiguous memory and technique, or second is it is non-contiguous technique. So in contiguous technique again further it is divided into two subways, that is one is fixed partition and second one is dynamic partition. And here in fixed partition means what happens, like main memory will be divided into two number static partitions at the system generation time. A process may be loaded into a partition or equal, it might be loaded into a partition of equal or greater size. So your maximum number of active processes will be fixed. The simplest partitioning method is divided like memory into several fixed sizes. Like in the partitions will be in advances. In advance, these are called as fixed partitions. Like each partition may contain exactly one process. Each partition will be containing exactly one process. This is about the fixed partition. If you want to explain about the dynamic partition, so dynamic partitions, they are created dynamically so that each process is loaded into a partition of exactly the same size as a process. Okay, and it is having many advantages and disadvantages also. And the next coming to the like paging, as you know, paging will be coming into this non-contiguous memory partitioning technique. So as we all know that paging is a memory management technique, so in which process address space is broken into, just in which this is process address space. Okay, for single process address space, it is broken into blocks of the same size, and it is called as a paging. And the size of the process is measured in the number of pages. Like normally, a computer can address more memory than the amount physically installed on the system. So this extra memory is actually called as virtual memory, and this paging technique plays an important role in implementing this kind of virtual memory. And the next is like, as we all know that like segmentation is nothing but it is also a memory management technique. Here what happens, in which each job is divided into several segments. Each job is divided into several segments of different sizes, and one for each model that contains pieces that perform related functions. Here each segment is actually a different logical address space of the program. So when the program is to be executed, its corresponding segmentation are loaded into non-contiguous memory through every segment. Non-contiguous memory through every segment is loaded into the contiguous block of available memory. And segmentation memory management works very similar to paging, but here segments are of variable length, whereas in paging, pages are of fixed size. This is all about, like in the next video I'm just going to explain in detail about this single as well as in this multiple partition, and the multiple partition regarding contiguous and non-contiguous techniques. Okay then, thank you.